In this series of films we will talk about industrial communication, how industry components communicate with each other, and we will start with RS232 and RS485. They are really old standards, and that's why I have called the presentation that the dinosaurs are still alive. And let's start with RS232, which is an abbreviation for Recommended Standard 232. It was introduced back in 1969, so it's over 50 years old, and it used to be the standard for serial communication from a PC. So for my first PC I used serial communication when I wanted to connect to other computers, for example. Now this has been replaced by USB, and parallel communication is no longer available as an input to a PC. But serial communication, the S in USB is for serial. But you will still find RS232 in the industry, since it's so robust and it's so reliable. And you will also find it by other names. For example, EIA RS232 or EIA 232 or TIA 232. But it's basically the same thing. So the correct way of naming it today is actually TIA 232. But everyone simply calls it RS232 still. So the version we are using now is TIA 232F, basically. And what is defined in the RS232 standard? Electrical properties, voltages, data rates, etc. Mechanical characteristics, that is what you see here in this figure, how the dimensions and the pins, how many pins, what the pins are used for, and that's actually functions. So these three are defined. If we study it in the OC model, you will see that they are all layer 1 properties. They are the properties concerned with how to transfer single bits from one station to another station. And here is an example with a sensor that is connected via RS232 to some computing device. For example, a PLC or something. And you see it's quite large, so it's quite robust, and it can handle quite a lot of vibrations, etc. The baud rate, which is about 19.2 kilobauds, is for a segment length of about 15 meters. So compared to modern communication, where you have 90 meters of 1 billion gigabits per second, you see that is extremely slow with an extremely short distance. So that's why it's a dinosaur in this setting. However, for communications like this, where you have a smart sensor here, you see that the communication doesn't have to be very fast, since the amount of data that this one is logging is maybe a few samples per second, so it doesn't have to be very fast. So by having such a low communication rate for such a short distance, you see that it's really robust and reliable. However, it's point to point. Since we only have level 1 or OC model level 1 properties, we do not have addressing, so therefore it's simply point to point from one sensor to one computer. The distance is short, the bitrate is slow, and the signaling is so-called single-ended signaling, which is that we have one common ground here, and all the signals here are measured with respect to that ground. So it's not like in modern communication over Ethernet cable, where you have twisted pairs. So for each set of communication you have forward and backwards. that requires more wires, but it's more reliable. So here is what the pins in an RS232 connection is used for, and you have transmit data, which goes to receive data on the other side. Transmit here goes to receive here. Request to send, and it's replied with a clear to send. Data terminal ready, and data set ready, and ground. So you have all this extra information here, which is really not necessary in modern communication. So therefore, a new standard appeared, which is called RS485. 485 has the one large benefit is that you may have up to 32 devices in the network, and also the distance goes up 1200 meters, and of course the communication rate is much faster. So this is a more modern way of doing it, and compared to Ethernet, it's simpler, and it's slower than Ethernet, but it has so-called real-time communication, which means that it's predictable how long it takes to communicate a certain message. This one came in 1983, so it's still a bit old, but again, very much used in the industry. You have something called a multi-drop, which is similar to bus. You have nodes here that connect to a central wire. You have local addressing, which means that you have up to 32 devices in a network, but the address doesn't contain any information on where nodes are. So it's not possible to build subnets, etc., like you can build with an Ethernet or TCP/IP based network. Usually you have something called a master-slave protocol, which is that one of the nodes is a master, and it sends a request to the other devices and gets a reply. So the only one that can initiate the communication is a master. So master sends a request and gets a reply, sends a request and gets a reply. So this node cannot communicate with this one here. But then again, if you think this is the central computer of a control system, for example a PLC, and these are sensors and actuators, why should a sensor talk directly to an actuator? It goes via the computer. So the computer asks the sensor, how warm is it at your site? And it replies, it's 60 degrees. And the computer gives a message to the valve to open for cooling. So start cooling, reply, started cooling. What's the temperature? And so on. So the computer here is the only one that initiates communication. It's also called client-server, where this is the client and this is the server. The client asks for data, so it wants to be served some data. Some examples. You have this one. This is a Bergen-based company, Clampon, where you can communicate by, for example, RS485. This is directly from the datasheet. And here is a pressure and a temperature sensor, which communicates by RS232 and RS485.